Okay, today we are going to be doing part 2 of our matrices unit. So after this lesson, you guys will have a M1 through M2 quiz. So make sure you're studying and doing your homework and getting ready for that quiz. So today we are going to be talking about solving multivariable linear systems. So remember, when I'm talking about multivariable systems, I'm not just talking about x and y, I'm also talking about a third variable z. So if we look at this here, last time we talked about back substitution and how we can use basically the concept of substitution in order to solve matrices. Well, what happens if I can't isolate one variable? So if I can't do that, then we would have to manipulate each row, each line, and we would have to start doing it by hand. And trying to get things to cancel out and eliminate is what we would really try to do. The nice thing is our calculator actually does it for us. These are the steps for a TI Inspire. So if you have a TI Inspire, you would follow these steps. If you do not have a TI Inspire, we are going to walk through it together in the TI 84. So that will be nice. So we're going to go ahead and solve these two systems in our calculator, and I'm going to show you how to do that. The main thing you need to be careful of is, let's see, somewhere you are going, here, make sure you're always choosing reduced row echelon form. Okay, that will give you a matrix that looks like this. I lied, I shouldn't have written it like that. That'll give you something that looks like this. Okay, reduced row echelon form is when you have ones along the diagonal, zeros everywhere else, and you have your answers over here. So this would be, remember, x, so 1x equals 2, 1y equals 3, 1z equals -1. So it's actually going to give us the answers. Okay, so if you are in a TI Inspire, go ahead and work through this very first one with this. And if you're in a TI 84, we're going to do these in the TI 84. Okay, so here's your calculator. You have a button here under your math button. It says matrix, this x to the -1. So you're actually, it's in blue, so you're going to hit the blue second button and then matrix, so x to the -1. And then you're going to go over to edit. Let's see if you can see this. And then I have a bunch of matrices already, but you would not have any matrices in A. So you're going to just click A. I'm going to go down to my first one that doesn't have any and click E. And we can see here that we have 3 rows and 4 columns. So it's a 3 by 4. And I'm just hitting enter after every time. And now it's going to come up with 12 different areas that have zeros. So now I'm just going to start filling in my first line. My first line, remember, you only fill in numbers. So 3, enter, 4, -1, 17, 5, -1, 2, -2, 2, -3, 7, -21. Okay, so remember, I'm getting those from my coefficients. I'm basically augmenting my matrix. All right, then you're going to go back to second matrix. So second x to the -1, and then you're going to scroll over to math, and you're going to go down to RREF. So not REF, we want reduced row echelon form. And I'm going to hit enter. Oh no. Go second quit. Sorry, you want to go back to your screen. Now you're going to go to math and then RREF. And then you're going to go second matrix again, and you're going to hit whatever letter your matrix is under. So I created my matrix under E, so I'm going to select E. And then once you have that, you can just hit enter again, and it will give you your augmented matrix. Okay, so let's write what we put into our calculator. So remember, we got rid of all the variables and the equal signs and the signs. So we had 3, 4, -1, 17, 5, -1, 2, -2, 2, -3, 7, -21. And when I put RREF into the calculator, I got 1, 0, 0, 1, 0, 1, 0, 3, 0, 0, 1, -2. Okay, so this tells me that x is equal to 1, y is equal to 3, z is equal to -2. Remember, this is the x column, y column, z column. So if x is equal to 1, y is equal to 3, and z is equal to -2, then that's a point, and we have to write our answers as points. So 1, 3, -2. All right, next one. So let's write what we're going to put in. So 1, -2, 3, 9. -1, 3. We're missing a z here, so we have to put a 0. So -1, 3, 0, -4. 2, -5, 5, 17. Okay, so that's what I'm going to put in my calculator. So I'm going to go back to matrix, and I'm going to go over to edit. I can edit any of these, by the way. So since A is already a 3x4, I'm just going to go ahead and edit it. Here you can obviously see I was working on a matrix that was a 3x4, but I'm going to go ahead and just fill in this with my new numbers. So 1, -2, 3, 9. So see how it's replacing my other numbers. Just make sure it's actually replacing them. -1, 3, 0, -4, and then 2, -5, 5, 17. Double check them to make sure they're right. Okay, so second quit. And then you're going to go second matrix again, and you're going to go down to RREF. And then you're going to go select your matrix. I used matrix A, and it should give you this. So it gives us 1, 0, 0, 1, 0, 1, 0, -1, and 0, 0, 1, 2. X equals 1. Y equals -1, Z equals 2. Write it as a point. So 1, -1, 2. Okay. Next page. All right, so again, you can write out what you're going to put in it first if you get confused, but I'm just going to start writing what I get out of my calculator. So here we're just going to start working through some. So I'm going to edit A again. It's a 3x4. I get 2, 1, -1, 7, 1, -2, 2, -9, 3, -1, 1, 5. Okay, and I'm just following these steps again. I used matrix A. Okay, so here It says 1, 0, 0, 0, 0, 1, negative 1, 0, and 0, 0, 0, 1. So the first line would tell me that x is equal to 0. That's totally fine. Here, this would tell me that y minus z equals 0, right? 1y minus 1z equals 0. And then it tells me that x is 0 here, y is 0 here, z is 0 here. Those added together would give me 1. So our last line here doesn't make sense. Zeros can never equal 1. I can't have 0 and a variable together. That doesn't make sense. 0 times a variable is 0. So this would tell me, this last line would tell me that 0 equals 1. Well, we know that's false. So think back to what false statements indicate our answer is. Okay, remember, false statements indicate that we have no solution. So in no solution matrices, that literally means that these 3 points will never touch. Okay, on a 3D graph, these 3 points will never intersect, and therefore we wouldn't have a solution. Okay, so next one. Same steps. So now my numbers are 1, 2, negative 7, negative 4, 2, 1, 1, 13, 3, 9, negative 36, negative 33. Okay. This one reads 1, 0, 3, 10, 0, 1, negative 5, negative 7. We should already see some red flags because it's not reduced row echelon. And then 0, 0, 0, 0. Okay, this bottom line, so the first red flag should be that these top 2 lines aren't reduced row echelon form, which means that our calculator literally couldn't get it. It could not get reduced row echelon form. So our last line here reads 0 equals 0. That's a true statement. 0 does equal 0. Okay, so now you have to think, what does a true statement mean for our solutions? Well, it means infinite solutions. Okay, last one. And then we get a word problem. Okay, matrix edit. You'll get fast at this. So 2, 4, negative 1, 7, 2, negative 4, 2, negative 6, 1, 4, 1, 0. Okay, so this one reads 1, 0, 0, 1. Cool, that's reduced row. 0, 1, 0, 0.5. 0, 0, 1, negative 3. Okay, so this is actually reduced row echelon. There's nothing else on, like, around our little square here of stair step. We do have answers. One of them is a decimal. Totally fine. I think sometimes we see a decimal and we freak out and we think that decimals can't be answers. Decimals can totally be answers. So here this is x is equal to 1, y is equal to 1/2, and z is equal to negative 3. It's a point. We have to write it as such. Okay. All right, so write a system of equations and then solve or use a matrix to solve. So in Super Bowl I, the Green Bay Packers beat the Kansas City Chiefs 35-10. The total points scored came from 13 different scoring plays of touchdowns, extra point kicks, and field goals. the number of touchdowns were the same as the number of extra point kicks, and there were 6 times as many touchdowns as field goals. How many total touchdowns, extra point kicks, and field goals were scored during the game? So we obviously have 3 variables. How many touchdowns? So I'm going to say X is touchdowns. Y is extra point kicks. And Z is field goals. Okay, remember whenever we have a word problem, we have to take a step back and we have to relate things that are actually related to each other. So the first thing we see is this 35-10 and the total points scored. Okay, so total points scored is actually 45. And we have to think where those total points came from. Okay, we know that there are, now, if we're talking about points, we're not going to be talking about a touchdown. We're going to be talking about how many points per touchdown. So we know that there are 6 points per X, 1 point per Y, so I'm just going to say plus Y, and 3 points for field goals. And those scoring plays with those points got to be 45 points total in the game. Another number it says is there are 13 different scoring plays. Okay, if there's 13 different scoring plays, we have to think of what those scoring plays are made of. 13 is just the number of plays, not how many points or how many other things happened. It's just what happened during the game. Well, during a football game, you can have touchdowns, extra point kicks, and field goals. So we would say that X plus Y plus Z is equal to 13. Okay, so we're done with that sentence. The next sentence is the number of touchdowns were the same as the number of extra point kicks. So we know that X is equal to Y. Now, we would have to move the Y over to make sure that we're still in that matrix form. There were 6 times as many touchdowns as field goals. Okay, so X is equal to 6 times Z. Here's why. You guys will always want to put the 6 on the X. If I have 3 touchdowns, right, or let's say I have 3 field goals, that means how many touchdowns would I have? Well, I would have to take my 6 times and multiply it by the 3 to figure out my touchdowns. So 6 times as many of my 3 field goals were my touchdowns. Okay, so I've got to make sure I've got equals numbers, no variables. My equal signs have to line up, my variables have to line up. So my first 2 equations are fine. I have to move this y over, so x minus y is equal to 0. And I've got to move that 6z over, so x minus 6z equals 0. All right. Now we can plug this in our calculator, so you're going to do your same steps. Here we have a 4x4, so I'm going to edit this b into a 4x4. All right, 6, 1, 3, 45, 1, 1, 1, 13, 1, negative 1, 0, 0, because my z is gone there, and then 1, 0, because I don't have a y, negative 6, 0. All right, quit. Go down to my 4x4, hit enter. Okay, so here's what we get out, and let's talk about what our solution will be. So 1, 0, 0, 6, 0, 1, 0, 6, 0, 1, 0, 0, 1, 1, and 0, 0, 0, 0. Now, we see that last line and we're like, oh my gosh, that's infinite solutions. However, if we take away this last line, we have actually a solution for each of our variables. The only thing is when all of our variables in the denominator cancel and we're left with a false statement, or we don't have what z equals. Well, here we have what z equals. So this tells us that x is equal to 6, y is equal to 6, and z is equal to 1. We don't have a fourth variable that would have canceled. We have actually an answer for all of our variables. So this means that there are 6 touchdowns, 6 extra point kicks, which is that one line that there are as many touchdowns as there are extra point kicks, and 1 field goal. So we have to make sure that these actually make sense in context to our problem. So here's our answers. Let's talk through our actual solutions. So 6 touchdowns would be 36 points. 6 extra point kicks would be 6 points. So 36 plus 6 is 42. And 1 field goal is that 3 points, which gets you to 45. 6 plus 6 is 12, plus another one is 13. That's 13 scoring plays. Touchdowns equals extra point kicks, that's true. And there are 6 times as many field goals, or as many touchdowns as there are field goals. 6 times my 1 field goal will give me my touchdowns. Okay, go ahead and flip to the next page and start working through your homework and make sure you're entering your answers on Canvas.